Good afternoon, gentlemen, and anybody else. We're getting to the end of our school year, and today we're going to be working on related rates, and specifically related rates with angles, which in my experience are some of the most challenging things in this calculus class. But I, working through these, found I was getting a lot better handle on it. So basically it's the same thing we went over first semester. You look for find, which we'll call F, when, and then our given is going to be our G, and then we put down our E for equation. So that's what we're going to be looking at. And drawing a sketch, seeing what it looks like. Robert, it's really good to have you here today. And so on the left, I'm going to put over here F, W, G, E. And I think this session today will be our second to last. I think next Thursday probably be our last session. I think seniors are going to be wrapping it up next week. That's good, guys. Anyway, we got a television camera at ground level is filming the liftoff, and so we got this camera at ground level right here. So here's our camera. There's our camera lens, and so the camera is filming this rocket takeoff like this. Here's the rocket going up like this. And the camera is 2,000 feet away from the launch pad. So here's 2,000 feet. And here's the line of sight to the rocket. And the rocket is going, according to the equation, S equals 15t squared, 50t squared. And so we're interested in where we are 10 seconds after liftoff. Okay, Ryan, it's good to see you too, Ryan. And so find the rate of change in the angle. So as the camera tracks the rocket ascending, that camera is going to pivot at a certain rate. So it's going to be an angular rotation, and the rate of change of that angular rotation is what we're looking for. So what is going to be, so we're going to find what is the rate of change in angle of elevation. So we're going to say d theta dt. So the change in the angle with respect to time. When 10 seconds after liftoff, so t is equal to 10 seconds. And given, okay, we're given the equation. We're given, we'll call this x, if you want to call this our adjacent or adjacent side of our triangle, is equal to 2,000, and we're given also S equals 50t squared. That's going to help us. And our equation, now, what equation do we have that relates this side over here? Now, as far as what this side is going to be, 50 and t is 10, right? 50 times 10 squared. Well, that's going to be equal to 5,000, right? So that's going to be this. So this is 5,000 here. Okay, and our equation, what is our equation that relates these things here? And as far as what the rocket is going, well, how do we find the rocket speed? Well, let's look at this here. We have s equals 50t squared. Well, velocity is going to be equal to s prime, which equals 2 times 50, so 100t. So we're going to have v of 10 seconds is going to be 100 times 10 equals 1,000 feet per second. So velocity equals 1,000 feet per second. I'm not sure if we're going to need that. Okay, what equation is going to relate everything here? Well, it's going to be tangent. Tangent theta is going to be equal to, we'll say, okay, so let's go ahead and put that equation into practice. We have tangent theta equals y over 2,000. So what we're going to do is take this equation and implicitly differentiate. Okay, what is the derivative of tangent? That's one thing that's really needed for these exercises. Okay, do you remember that, we wrote down tan, secant, remember that? So if we want the derivative of tangent, if we cross out tan, we have secant squared. So what we have on the left here is secant squared theta, and we have d theta dt. And on the right, the derivative of y is y prime. So we're going to have dy dt, dy dt over 2,000. Okay, now to solve for d theta dt, if we divide both sides by secant squared theta, so we have this other side divided by secant squared theta. Okay, so we have that, and now we're going to be able just to start solving. Well, what is secant squared theta? What is that equal to? Well, that's equal to 1 over cosine squared theta. Okay, so now what we're going to have is d theta dt that's going to be equal to this. We have v prime dy dt, that's 1,000 feet per second divided by 2,000 And then we're going to have reciprocal of secant is cosine, so it's going to be times cosine squared of this angle. What is that going to be? Let's figure it out. What do we need for cosine? We need adjacent and we need hypotenuse. So hypotenuse is going to be equal to the square root of, using Pythagorean theorem, 2,000 squared plus 5,000 squared. So let's go to calculator and get that. Square root of 2,000 squared plus 5,000 squared. Now it doesn't list this problem as a calculator problem. Okay, 5385, and you could say 5385.2. So 5385.2. So what we're going to have here is d theta dt. I'm just going to write out the numbers here. We're going to have, it's going to be equal to this 1,000 over 2,000 times cosine squared theta, which is going to be, cosine is going to be 2,000 over 5385. And we're going to square all this out. And so so let's go look at this in our calculator. 1,000 over 2,000, that's going to be 0.5. So it'll be 0.5 times, we're going to go to 2,000 over, what was that? 5385. Come out here, square it. So we square it. So we get 0.6, looks like 0.06, 0.0689. That would round off to 0.0690. 0.0690. And that's going to be radians per second, because we're looking at seconds, right? So that's the rate of change of angle here, radians per second. And just before we go on to the next problem, what I want to do is we're going to change that into degrees, just so you get an idea of how many degrees per second that is. So we're going to multiply that by 180 over pi to convert to degrees. And for that we get, so about 3.95 degrees per second, which you could probably see that. Should make a little bit of sense to you, I hope. Okay, so that will be our answer here. And we're going to do this one here. And work ahead with me, or ahead of me, as fast as you can on this one. I have some little glitches with the resources involved in the computer. This one I think is maybe a little bit easier than the other one. Okay. Plane at altitude of 4,000 feet. So you have this plane. I'm just going to save this drawing here. So here's the plane, and I just drew ground level beneath it, and so we're 4,000 feet is what we are here. And it's flying west at 700 feet per second. And we'll call this dx dt, just like an xy coordinate plane. And since we're going to the left, we'll call that negative. A searchlight under its path tracks the plane. How fast is light pivoting when the plane is 1,000 feet east of the light? Well, here's the plane. Here's the ground level. If the plane is east of the light has to be west, 1,000 feet west of the plane. So we'll say here's our light here. Okay, we got this searchlight right here that's going to be shining on this plane going this way, and this is 1,000 feet here. The plane's 1,000 to the west. So let's see what we have here. FWGE. So find, we have light pivoting. So again, it's going to be like that last one, d theta dt, when this is going to be x. Well, if you say this is x here, if this is xy coordinate plane, xy, we'll say x is equal to 1,000, and y is always equal to 4,000. We know that. Well, I guess that's about it. Given dx dt is equal to negative 700 feet per second. What is our equation going to be? Well, we're going this direction. So, equation, what do we have? Well, we're going this way, and a tangent. So we have tangent theta, because we'll say this is theta right here. Tangent theta equals our opposite side, which is 4,000, over x, right? Over x. So now we're going to go ahead and take, I'm going to leave a little more room on the right side here. We're going to say tangent theta equals 4,000, and we have x sitting here in the denominator. I'm going to say that's going to be x to the negative 1 power. And you know why I'm doing this, I hope, right? Okay, let's take the derivative of both sides of this equation. And just like in the last problem, we have d theta dt times secant squared theta is equal to, what do we do to take the derivative of this thing here? Well, we have negative 1 times 4,000, so that's going to be negative 4,000 times x to the negative 2 power. So I'm going to write x to the negative 2 power as x squared down here. Okay. Now again, we're going to divide by secant squared theta, both sides. So here we put secant squared theta here. So d theta dt is equal to negative 4,000 over x squared, and x is going to be 1,000 squared, right? Times the reciprocal of secant is cosine again, and cosine is going to be adjacent over hypotenuse. And what is our hypotenuse? Well, it's going to be square root of 1,000 squared plus 4,000 squared. So hypotenuse is going to be equal to, go to calculator, $1,000 Does this look pretty hard, what we're doing here? Because I'm telling you, this is, in my years of teaching calculus, this is one of the things that I have to review for most carefully when it comes time to teach it. 4123.1. That's 23.1. So now we're going to have our cosine squared theta is going to be our adjacent over 4123.1 and we're going to square all this. That's 0.1. And we're going to square all this here. So here we go. So we have, first of all, negative there's something that's messed up here. Hang on a second. Because we should see a positive rotation here. We got a negative, negative, and we have dx. Yeah, hang on a second. I forgot something, didn't I? We have dx dt also, which is going to be negative 700. I knew there was something amiss, right? Because we have to have dx dt when we took the derivative of this x here. It was times dx dt. Boy, I'm glad I remember that. So negative 4,000 over 1,000 squared. That would be that x squared times we have 1,000 over, I'm going to put second ANS because that's the last thing calculated here, and we'll square that, and we're going to multiply by negative 700. There we go. So we get 0.1647 radians per second. That's going to be radians per second. Okay, yeah. Okay. Did you see Harry just made that comment down there? Okay, let's just, and really as far as what that'll be in degrees, as we multiply by 180 over pi. So we get 9.44 degrees per second is what that looks like. So anyway, this will be our answer here. And that's as far as I want to go today. As far as what we're going to be doing, I'm going to plan to do a video on, to have you watch a video early next week on Monday perhaps, of these next three problems, related rates and implicit differentiation practice. This 1, 2, 3. And so that'll be early next week. And then next Thursday for the last live session, we're just going to have these two implicit differentiation problems. This one here, number 4, and this one here, number 5. I guess the 4 is a trigonometry one, 5 is not. Anyway, that'll be it for today, gentlemen. I do appreciate you being here. Do you have anything else to say before I get off? I think I'm about 30 seconds ahead of what I'm going to see here. I'll just wait half a minute. Well, I do appreciate both of you being here today. It really shows dedication that you guys are staying here to the last of the school year. Give you guys a lot of credit. Okay. Well, good. I'm going to just log off. I'll see your comments after I hit end stream probably, but that's all right. Take care, gentlemen. Have a good day, a good weekend, and we will get back on the rest of the next week. Thanks. Bye.